So today we're going to take a look at the distributive property. This is something that we studied last year, I would say shortly into semester 2, and then we looked at it at the very, very end of the school year. So hopefully you find that this lesson you remember it from last year. So we're going to review it today. Tomorrow we're going to add a new piece to it that we didn't do last year, and then we're going to kind of keep doing more review with it. And just so you guys know, I don't know why these weird red lines are there, so hopefully they're not distracting to you guys as you're going through this. I need to look into it later, but I don't want to worry about it right now. So when we take a look at the distributive property, first we want to take a look at a vocabulary word that's called the coefficient. And the coefficient is the number in front of the variable. I like to call it the first name of the term. So the number, which is the coefficient, is the first name, and the letter is going to be the last name of it. And we're going to talk more about that last name tomorrow when we take a look at like terms. So if I take a look at x, the coefficient of x is 1 because, again, mathematicians are lazy and they got tired of writing that silly 1 in front of it. So that number in front of that x is really 1. The coefficient, if we take a look at 3x, is 3 because that's the number in front of x. If we take a look at negative x, again, there's not a number there, there's just a negative sign. Again, mathematicians got a little lazy, got tired of writing that 1 in front of it. So this coefficient is actually -1 because that's the first name of our letter. Okay? So we're going to be taking a look at that as we're using the distributive property and working with some of those coefficients. The distributive property is shown here. I'm going to show it here in a little bit in a better way. But the big thing with the distributive property is our goal is to always get rid of the parentheses. We can also use it here to make some of our multiplying and adding a little bit easier. We're going to be doing mostly algebraic stuff, so you won't see anything like these examples. But just something we did a little bit with it last year. So as I mentioned, the goal of the distributive property is to get rid of the parentheses. So when we rewrite it, we're not going to have any parentheses at all. These are the 4 types that you could see. In this first one, we see A, and we'd read this as A times parentheses B plus C. So notice what we're doing is we're taking A times B and then hopping over to A times C. Going to the next one, same thing here, but now you'll notice there's a minus sign inside the parentheses, but the process is still the same. I'm still hopping that A over into the parentheses to get A times B. This example shows us a minus sign. I'm actually going to show you a better way to kind of help you with these, but you'll notice this one does have a minus sign here. And then we're going to hop and do A times C to get the second parts. These first 2 examples had A in front of the parentheses, but remember the commutative property says we can multiply in any order. So as we look at these bottom 2 examples, they're the same thing, but notice we say parentheses times A. So that A is still being multiplied to the parentheses, so we can still distribute, but now we're distributing from the back end. So I'm going to go A up to B and get my BA. Then A to C to get here. I will tell you guys as we go through our examples, these 2 can be in any order. It does not matter which one's written first. It's all in your preference. I will tend to do it the way that they have it here, but you could have CA first and then BA. Does not matter. And then as I look at the other one again, this one is a minus sign, but that A is still going all the way to the B, and the A is going to the C. To get BA and then CA, but a minus sign in front. Okay? So as we're going through, and if it says simplify and you see parentheses, it's because we're trying to use the distributive property to get rid of the parentheses. Before we do this, I want to talk about some things you're going to see as we go through our distributive property lessons the next several days. When we're adding variables, so you'll notice on this one we have x plus x. So we're adding here. You keep the variable the same. So if you were to look at this, you would tell me how many x's do we have? You would say, Mrs. Holland, we have 2 x's. Because you add those coefficients or the first name of the variable together, and you have 1x plus 1x, you have 2x's there altogether. Again, that's when we're adding exponents. When you're multiplying exponents like we see in this one, this is a really, really important thing that sometimes students struggle with. This is something we're going to focus on today. When you see that we are multiplying exponents, you end up adding the exponents together. So again, mathematicians are lazy. There's not an exponent written there, but it's implied that there's a 1. So x times x is x squared, which hopefully makes sense because we saw stuff like this on your last quiz that you just did on Tuesday. That if you were to write this out, you would say x squared means the same thing as x times x. So these two mean the same thing. So anytime you say x times x, think about needing an x squared because you're adding the exponents. This is something as other math teachers use. It might help you to kind of just make sense of this. So if you were to see 2 zebras, like you go to the zoo and you see 2 zebras, you would say, Mrs. Haugen, I just saw 2 zebras at the zoo. We can't really multiply zebras at all. Like you wouldn't say a zebra times a zebra gives you 2 zebras at all. This doesn't work at all for us. So think about the zebra example that you could add 2 zebras together. You can't multiply 2 zebras. So that's why we don't say that there's 2 zebras here. Again, just an example, something to help make you maybe process this piece, but we'll really work on both of these tomorrow. So let's take a look at actually simplifying some expressions, okay? First thing that we're always going to look for is we're going to look to see, do we have any subtraction signs? We stressed last year, subtraction is like an enemy to us. We don't like it. So we're going to do our keep, change, or if you had the phrase add up last year. So as I look at example A, there's no subtraction signs, so I'm going to go ahead and distribute. The 4 is being multiplied times the parentheses. So my 4 is going to do the hopping. So I'm going to do 4 multiplied by 3. When you hop to the next part, always, always, always put a plus sign here, always. Now that 4 is going to hop to the next part. So I'm going to think about what's 4 times 6x. We've written it out. Now we actually multiply. 4 times 3 is 12, plus 4 times 6 is 24, and the x stays along. For today, you're not going to need to worry about looking for any like terms. We'll worry about that tomorrow. These two end up are not like, and again, we'll review why that is tomorrow. Now let's take a look at example B. On example B, now I see that there's a subtraction sign, so we're going to do our keep, change, and then this y doesn't have a number in front of it, so I'm going to squeeze in a little 1 there. So I need to think about that being a negative 1y. Now I have to think about what number is being multiplied times the parentheses. It's always going to be outside the parentheses. And that happens to be where you read this as negative 3 times parentheses negative 2 plus a negative 1y. So the negative 3 is doing the hopping. So let's hop. Negative 3 times negative 2 plus negative 3 times a negative 1y. So I'm going to be writing them out like this. As you get more comfortable, this step can be skipped on your homework, and I'm fine with that as long as you're not making any mistakes. And if you just write the answer, that's fine with me. If I see that you are making a lot of mistakes, then I'm going to have a conversation with you, and then you have to show me this step here. Okay? But if you can do this in your head, that's fine. So now we're going to multiply. Be very, very careful here. A negative times a negative becomes a positive, And make sure you multiply. 3 times 2 is 6. Plus -3 times -1 is +3. And I only have that y, so it gets tacked on. So we end up with 6 plus 3y. All right, let's take a look at example C. On example C, again, I see subtraction, so I'm going to do keep, change, or add up. And that n doesn't have a number, so I'm going to put a 1 in front of it. So I'm going to think about that as a -1n. Now this one's a little bit different because you'll notice I have 2 parentheses. This first set of parentheses, again, is only used to set off that -4. It tells the reader that, hey, that's the number -4, and makes it just easier to see. So we would still read this as -4 times parentheses 6 plus a -1n. So that -4 is the number that's doing the hopping. So I'm going to have -4 times 6 plus, again, always put a plus sign before you do your next hop. Students who don't, they make mistakes and they get signs incorrect. We don't want that to happen, so always put a plus sign there. -4 times a -1n. Multiply. So once you've distributed everything, because that's what we just did, now we actually multiply. -4 times 6 is a -24 plus -4 times a -1n. Multiply the numbers, attach to the n. There's our answer. Now let's take a look at D. Hopefully you guys are looking at that one and saying, well, that's interesting. There's a negative in front of the parentheses. Well, if there's not a number there, what number must it be there? Again, thinking that mathematicians are kind of lazy. That number is 1. Again, mathematicians, they got tired of writing that number 1, so they don't write it very often. So if you don't see it, it's implied that there's a 1. So we're going to take -1 and multiply it through the parentheses. But before we do that, we have to do our keep, change first. So I'm going to do -1 times 6. Always put a plus sign as you move to the next one. -1 times a -3x. Whenever you do keep, change here, make sure your negative is big enough so that way you don't forget it. I see all the time students make that negative so small and they forget about it in this next step. So make sure you can see that negative so you don't forget about it. Multiplying. -1 times 6 is -6 plus -1 times a -3x. Negative times a negative becomes a positive. All right, I would like you guys to go ahead and try these 2 examples for me. Sub, you can go ahead and press pause. When it looks like most students are done, go ahead and press play, and you'll be able to see the answers. If anyone has questions, please have a conversation about it. Help each other out, because I know that you guys are great students and you'll be able to figure it out. All right, go ahead and take a look at these 2. On example E, you should have ended up with 4x plus a -12. And on an example F, you should have ended up with 2x plus a -12. Let's go ahead and take a look at those. If you have questions, help each other out on these. Okay, so these next type of examples, these are actually going to be a little bit new from what we did last year. You'll start to notice on these, the number that we are going to be distributing through the parentheses now has a variable with it, okay? So this is where we're going to think about when we're multiplying, what we do when we multiply with our variables. On example G, I have a plus sign, all good. Number being multiplied by the parentheses, that whole piece is going to go into the parentheses. So we're going to have 2x times x plus 2x times 1. Now be very careful here. This one here, we read this as 2x times x. Bells and whistles should be going off because Mrs. Haugen just said x times x. And whenever we say x times x, that becomes an x squared. So anytime you have an x squared, or x times x, it becomes an x squared. Plus, this one we read this as 2x times 1. I didn't say another x at all, so this one just stays as 2x. Again, we're going to talk about tomorrow. These two are not like terms because they have different last names. They're close, but not exactly the same. So we stop right there. In example H, first thing, I see that silly subtraction, so keep, change. Again, the number, the term I should say, that's outside the parentheses and being multiplied is what's going to go to each part inside. So I have 3x times 5x plus 3x times negative 8. Let's multiply. 3x times 5x. Oh, I just said times another x. So I'm going to multiply the numbers. And then the x becomes x squared because you said x times x. If you see multiples of there and you're multiplying, it becomes an x squared because we added our exponents. Plus 3x times a negative 8. That time we didn't say another x at all, so we just multiply the numbers and that x comes along. And again, today don't worry about any like terms because these are not like. We'll really stress that why that is tomorrow. All right, let's look at these two. On example I, first thing, darn subtraction. So I'm going to do keep, change. On example I, you can always add the 1 in front of those x's. You don't have to. It's always your choice. I would say half my students do, half my students don't. It's up to you. So we're going to take our 1x that's outside the parentheses and bring it through. So 1x times 1x plus, again, still with these, you always put a plus sign before you hop to the next one. And I don't know if you've been noticing, but I'm drawing these little rainbows as I'm distributing. The reason for it is it helps to make sure I don't miss anything, that I distribute to both parts inside the parentheses. Seems silly, but you'd be surprised how many students forget the second rainbow. So by doing both of them, as we're going through them, we don't miss anything. 1x times 1x. Woo, bells and whistles. I'm going to end up with an x squared plus 1x times a negative 3 is a negative 3x. There's our answer. Example J is the first one we've seen like this where the parentheses come first and the number that's being multiplied is behind the parentheses. You would still read this as parentheses 3x plus 4 times 2x. So this 2x is what's being multiplied into the parentheses. Now here's where it doesn't matter. I always go to the very front of the parentheses, but it doesn't matter which part you go to first. You're going to come up with the same answer, just a different order, which is fine. So we're going to do 2x times 3x plus 2x, hopping to that other part, times 4. 2x times 3x, bells and whistles. Make sure you multiply those numbers and make it be an x squared. Plus 2x times 4. I didn't say x times x, so it's just 8x on this one. There's your answer. All right, I would like you guys to go ahead and try K and L for these two, just like last time. Go ahead and press pause when everyone's done. Go ahead and press play so you can see the answers and see if you can help each other out in case someone got stuck. All right, taking a look at these. These ones again, you ended up with an x squared in both of them. So in example K, negative 1x squared plus 7x. On example L, 5x squared plus a negative 30x. Help each other out if anyone got stuck. Then the rest of the time is going to be yours to work on the distributive property worksheet, which is due tomorrow. Then, looking ahead, distributive property quiz, I moved that to next week Friday. So you'll have that on Friday next week. And also, big thing, just remember, Chapter 1 or Unit 1 end date is on Wednesday. After Wednesday, I'm not taking anything from Unit 1. All your retakes, missing assignments, redos, all of those things are due Wednesday by 3 o'clock. Have a great rest of your day, and I'll see you guys tomorrow.